Okay, so as we increase exercise intensity, we increase carbohydrate use, in part because we've got this push from PDH, this phosphodehydrogenase complex activity goes up because now we're getting more pyruvate into the mitochondria. So then the question is, why are we shifting to carbohydrate use completely, and where's the carbohydrate coming from? So the first thing is, if you look, what's happening from the plasma side of things? Are we using fat or sugar from the plasma? You can see that there's a shift as we increase exercise intensity. The contribution of liver glycogen to our exercise is going up. So we're getting more of a breakdown of glycogen in the liver. So that's one thing. But the biggest contribution is this huge increase in muscle glycogen utilization. So we're getting this really, really big increase in how much of the glycogen within your muscle you're breaking down and using as a fuel. All right, so now let's take a look at that closely and try and figure out what's happening here. All right, and this is related to why we start to see this increase in lactate with increasing intensities. This has always been an association where, oh, look, lactate's going way up. Oh, I'm feeling really crummy. I'm not able to sustain exercise anymore. It has to be because of lactate doing something that's shutting my body down. But you can see here that if we look at heart rate in the red, and you go from easy up to unsustainable, that's a linear increase in heart rate. And we're going to see that that's just a standard thing that happens, and that's one of the things that we look at as far as your ability to work at a high level. You're going to go between resting and your maximal heart rate, and it's a relatively linear increase with increasing exercise intensity. The difference is that if you look at lactate, it goes up. There's a first inflection point here called one of the lactate thresholds, and then there's a second lactate threshold where it becomes exponential increases in lactate with exercise intensity. And this is the unsustainable level of exercise intensity. So why is it that the exercise is going up in a fairly linear way? Your body seems to be responding in a linear way, but at some threshold, you get this increase, massive increase in lactate. As your, in this case, power, because this is done on the bike, as your power increases, now you're getting to a point where you can't sustain that and you're generating much more lactate, or you're accumulating much more lactate. So why is this? Well, let's first take a look at low intensity exercise and high intensity exercise and look at the different types of fibers you recruit during this. So at low intensity exercise, these are your slow twitch fibers. And what you're going to look at in your slow twitch fibers is the black indicates that they're completely full of glycogen. The white indicates that they have no glycogen left in them. The stripes indicate that they have a small amount of glycogen, and the dots indicate that they have a moderate amount of glycogen. So when you start and you go 0, 40, 120, 180, so this should say that this is now going for a longer work period because this is low intensity exercise. The top one is 0, this one's 40, 120, and 180 minutes. If you look at your slow twitch fibers, you're depleting the glycogen with your slow twitch fibers, low intensity exercise for a long duration. Let's look at your fast twitch fibers. Now, your fast twitch fibers are barely depleting any glycogen at all, because at low intensity exercise, you don't recruit your fast twitch fibers. You don't recruit your fast fatigable motor units. All right, let's look at instead now at high intensity exercise. Instead of going for 180 minutes, we're going for 20 minutes now. So this is super high intensity exercise. You start, you got full glycogen in both your fast and slow twitch. Now you're going to start going 3 minutes, 9 minutes, 15, 20 minutes in. You're depleting your slow twitch, but you're not depleting it that much more differently than your low intensity. The difference is here. Now you're depleting your fast twitch fibers of glycogen, which means you're recruiting your fast twitch fibers. So one reason we're shifting to using more carbohydrate as a fuel, and the one reason why we're shifting to increasing lactate production, is because as we increase exercise intensity, now we're going to start recruiting muscle fibers that are the big, strong muscle fibers. And the big, strong muscle fibers have fewer mitochondria in them. And because they have fewer mitochondria, you're breaking down glucose or glycogen into glucose, but that glucose now is going to go through glycolysis to pyruvate. And if you don't have enough mitochondria to take up the pyruvate and convert it into acetyl-CoA and to drive oxidative metabolism, you have to convert that into lactate instead. And so as I increase my exercise intensity, I'm going to increase the number of these big, huge motor units with few mitochondria that I'm going to recruit. And so I'm going to start producing more energy from glycolysis, and that's going to result in the production of more lactate. So as I increase my exercise intensity, I get these big old huge muscle fibers. They don't have enough mitochondria to really channel it and to have that sugar go into those mitochondria and produce energy aerobically. So now what has to happen is that energy we're producing, we're going to get to pyruvate. We've produced some ATP, but now in order to keep this going, we need to get rid of the pyruvate, regenerate NAD. And in order to do that, we produce lactate, and that goes out into the circulation. So again, if we look at our mitochondrial mass, here are our 2As. So this is type 1 myosin heavy chain, type 2A myosin heavy chain. So this is a 2X fiber. This is a 2A fiber. This is a combined 2A, 2X fiber. And then if you look at mitochondrial mass, look at our 2X fibers here and here and here. They have very low levels of SDH, which is a marker of the mitochondria. So the bigger, you can see this is a much bigger muscle fiber than the type 1 or the 2A. So it's a bigger fiber, but you can see also that it has much, much less of the mitochondrial proteins. And because it has fewer mitochondria, now it can't produce energy aerobically. So it's got to use more glycolysis, it's going to produce more lactate.